Welcome back to Green. Francesco and Emma here. Carbon fiber is one of the most important materials in modern engineering. It makes airplanes lighter, electric vehicles faster, and wind turbines stronger. There is a problem. Producing carbon fiber is extremely energy intensive. Manufacturing can generate huge amount of waste, and at the end of life, these composites are notoriously difficult to recycle. So can one of the most advanced materials in the world actually become circular? Today, we're speaking with Gary Owen from Lineat, a company developing technologies to recover and reuse carbon fiber at industrial scale.
Gary, welcome to Raw Green. So carbon fiber seems like the perfect material for modern engineering. It's light, strong, durable. There's a clue in the name, but structurally, it's one of the hardest materials to recycle. What exactly makes it so difficult?
Well, it's in its inherent manufacturing process. You're talking of temperatures of north of 1500 degrees C.
Wow.
So when you put them through a normal kind of recycling process, nothing happens to them. So it's not like a metal where you can melt it down to the raw material. You're left with the fibers. So it's a difficult material to recycle, and particularly from the energy perspective, you're putting a lot of energy in it to try and reclaim it.
So are companies trying to recycle carbon fiber because of sustainability goals, or because landfill restrictions and disposal costs are becoming a problem?
I think a combination of both, Francesca, to be honest, because, you know, the sustainability side is fantastic, but we should also look at the economics. It's a very wasteful material. When you manufacture the raw fiber at the beginning, you've got a 10 to 15% wastage. When you manufacture a component, say a wheel, you could have up to 35% wastage in offcuts. And then, as you said, at the end of life, you can't recycle it. So from a pure economics, going through the manufacturing process, you should be looking to try and put this back into the supply chain somehow, because it is a very expensive material.
It is.
So what are the biggest technical barriers preventing large-scale recycling today, Gary?
Well, as we touched on there, the components that it goes into are so varied. So from aeroplane wings to bike frames to ice hockey sticks, everything has got carbon fiber in. So all those different shapes, if you reclaim, so recycling of carbon fiber is a two-step process. You have the reclamation, where you take the resin out, so the resin and the fibers, you take the resin out, so you're left with the fibers. And then there's a recycling, the using of these reclaimed fibers. Once a part has been reclaimed, you can imagine the fibers in a tennis racket are different than in a cycle wheel, different than in an aeroplane, different from an offcut. So you've got lots of different sizes, shapes, lengths of fibers. So I think that's where our process come in, because we have a continuous short fiber. So kind of oxymoron there, continuous short fiber, but we have the same length fiber. So all those variables get chopped down to a 5 millimeter, 6 millimeter length, and then we can use them. When they're reclaimed, you can't really use a meter long and a 4 millimeter fiber together. They've got to be in the same format, and that's kind of where our process comes in.
Why do they have to be in the same format?
Well, as you can imagine, if you've got something that's 2 meters long, say from an aircraft wing, and then you're trying to mate it with a tennis racket, which might have a 50 mil fiber, it's difficult to combine the fibers together. The easiest one, which a lot of people talk about, is the reclamation and reuse of the high pressure vessels, because that's a filament wound high pressure barrel. So if you can take the resin off, you have a continuous fiber. But that's in the future. That's not now. Everything is chopped up into small parts at the moment. So you can imagine an aeroplane wing, to align those fibers in the strict manner they're being designed in. There's lots of small offcuts, triangles, rectangles, whatever, all in a big mass. That has to be somehow formatted so we can go through a process. So currently, the recycled material that is available is chopped up into a random mat. So it's not a very high specification material. So you kind of lose a lot of the original unique properties of carbon fiber.
So I just want to jump in at this point because you're making it actually sound a lot more diverse than I was aware of. For people who don't work with these composites every day, Gary, tell me actually what actually is carbon fiber and why is it so strong? Where do the material properties come from?
Well, you can imagine it's carbon. It's the base atom of
Pure
everything
carbon.
around us. Pure carbon. You must have heard everybody's talking about graphene,
Yes.
the ultimate material, and that is single atomic layer material, which is, even though people say it's a fantastic material, it's not actually usable because it's in such a small one layer atomic layer thing. Whereas carbon is a combination of those, so it's basically a usable version of graphene in its form. So it's a yarn. It's extruded as a yarn. So if you think like a polyester yarn that you get in your garments or even wool, so it's a yarn, and that's woven together or in some formats put through what we call a unidirectional, so a continuous yarn in one direction. And that's then your designers will take the specifications of that material and design that into the components.
So what are the biggest misconceptions that people have about carbon fiber, and particularly around sustainability, Gary?
Well, I think Francesca kind of mentioned that at the very beginning, because it's lightweight. You think you're saving. And it's kind of it's dirty secret that it's very difficult to recycle. So everybody's jumping not on the bandwagon, but saying carbon fiber is going to revolutionize aerospace and automotive. It's going to lightweight cars so they can go further with the electric. But everybody's forgetting about, one, it's a very expensive material. Two, it's quite wasteful. And three, you can't recycle it. So they're kind of ignoring those factors a little bit and saying this material's brilliant. It can, halve the weight of an electric vehicle wheel, so it'll go further. Isn't that good? Yes, but.
Yeah.
So I think people forget that a lot when they come up with a material. And it hasn't been around for that long, carbon fiber. And I think that's why, there's not been that much work done on the reclamation and recycling of it. We're still early stages, really.
The reality, though, it is that there is an explosion in the use and consumption of carbon fiber. The demand, it is skyrocketed. I was reading some data that between 2010 and 2023, consumption of carbon fiber increased 168%. And could grow another further 100+% by 2030. So the demand, it is there, and obviously, giving what we said as of now about the wasteful manufacturing practices and the non-circularity of the product, there is a dramatic need for solutions. Can you break down a little bit how Lineat works?
So Lineat Composites is a recycling company. So we take reclaimed waste carbon fiber, and we're trying to be as agnostic as possible. You can imagine at the beginning with a business, it's very difficult. You find the fiber you like and you stick to it, but we're trying to be as agnostic as possible. So when I mentioned before that recycling of carbon fiber is a two-step process, you have the reclamation. So take an example, a bike frame. So a bike frame is made of carbon fiber, lots of bits of metal, which is difficult, and resin. Resin's holding those fibers together. So somebody's got to take all the metal bits off, and then that frame will then go through a process, either a pyrolysis, which is heat, solvolysis, which is chemical, or pressolysis, which is superheated steam. That gets rid of the resin. Those three systems are probably covered by about 20 companies around the world. It's nothing new. Pyrolysis is used for reclaiming of tires, everything like that. So
PVC,
there's lots of feedstock people. So we work alongside these reclaimers and we get the waste fibers. And as I said before, our process is and some people hate it when we say this, is an advanced paper making process.
Right.
So
Okay.
with paper, you mix fibers in water, you try and make them as random as possible,
Yeah.
and then you suck out the water, you dry the paper, and you have a product. What we do with our fibers, we mix them in water,
Yeah.
and we try to disperse these fibers. You can imagine they're between 4 and 6 millimeters long, and they're 7 micron diameter, so extremely smaller than your hair on the head. We disperse those so there's not 2 fibers together, so individual fibers. We then bring them back together again through our kind of alignment patented process, and we make an aligned material as opposed to random orientated, which means it can be reintroduced further up into the supply chain, so adding value to the waste, but also being used in more high spec components back to where it was. To give you an example, back when we first started, we did a circularity project with World Sailing, and we looked at 4 different sports. Tennis was one of the ones that worked out superbly. It was amazing how we took broken tennis rackets, Lawrence, our CTO, and myself, we cut them down to size, we sent them off to be reclaimed. That process was a pressolysis, so superheated steam. They extracted the resin, sent the fibers back, we made a tape. Lawrence flew over to America, went to the Wilson R&D Center, and made a tennis racket. So really completing the complete circularity. So showing the end of life can be good. We, at the moment, concentrate on industrial waste because, we know that end of life is a kind of the golden chalice at the end of the rainbow. It's what everybody wants to focus on. It's what everybody wants to hear about. However, as I just mentioned, it's a very wasteful material all the way through its production.
Yeah.
So there's lots
40%.
of
Yeah.
exactly.
Yeah.
So we're concentrating on that because it's hundreds, if not thousands, of tons per annum.
Why is it so wasteful, Gary? What's going wrong there as to producing that much waste in the middle of the supply chain? Because this stuff's not cheap.
No, exactly. I think because, and I'm not an aerospace composites engineer here, so all the people listening to this, please don't go, oh my God, what's he saying? Because the fibers are in one direction or 2 directions in a normal woven material, you have to align those fibers with the loads in the component. So the designers lay up the material in a specific way, and that's why it is also quite a manual process. So you're laying up fibers in a 30-degree angle or a 45-degree angle or 20-degree angle to take the loads going through that component, whether it be a bike wheel, a wing of an A350 or a tennis racket. So if they're not going in that direction, they're cut off and it goes into the bin.
That's interesting. So they're actually making the material according to its use from its initial component parts. They're not just taking a sheet of carbon fiber and cutting it to size, so to speak.
No. So normally material comes in 1 meter wide, different grades in aerial weights ranging from very ultra lightweight to 600 grams square meter. Our material sweet spot is in the light end, so very formable. And then, they will cut it into all different shapes, then manually place it into a mold, for instance, and that's how you get the component.
All right, interesting.
Sorry, Gary, if I want to give a practical example of the product that comes out from your process. If I am a Airbus, Jaguar Land Rover, or a Formula One team, how could I use your product to what specific application?
So, as I mentioned, the aerial weight of material varies from 10 grams a square meter up to 600, 1,000. In different applications, people lay up fabrics in a multiply orientation. So you might have lots of different layers of material, but if you're trying to put down as much material in one go, that's when you want the heavier materials. So for instance, like boat building, you're laying up quite thick layers of carbon fiber. So you might use a 500 gram material. Aerospace, and not just Airbus. So once it goes into space, I've forgotten the analogy now. I think it's for every kilogram saved in space, it's $1 million. For every kilogram saved in an airplane, it's 100,000. In a car, it's 10,000, etc., etc. So the kind of the higher the spec, the component, the more people are very precise. But our material is a lightweight material by its way it's produced. So, but what we've been finding is that it has some quite unique properties, and I think that's the thing that drew me to this. You know, I don't know what I call myself, a sustainable commercial. So I'm driven by the sustainability and the environmental side, but I also want to make money.
Yeah.
And it has to, you know, it has to make money. It has to be economical to use this material. And when I was speaking with the people that invented the process at Bristol University, it has some quite cool, unique properties that mean, yes, it's sustainable. It's been made from end-of-life components, but it's extremely formable, so it can conform to some really complex shapes better than virgin carbon fiber can.
Really?
So all of a sudden that opens the green door opens, because everybody wants to talk about recycled products, but then it's like, wow, okay, these properties, that's interesting. And another one of these is because of the short fibers, due to its short fiber orientation, it absorbs energy better than the continuous fiber. So it can reduce vibration, it can reduce dampening. So all different sectors across aerospace, automotive, sports, that has an enhanced property. So that kind of drew me into this, I'd say. So that's where people can use our material.
And it still holds the original strength and stiffness that you would expect.
That was exactly my question.
So across all the properties, stiffness, flexural, modulus, tensile, all the different properties, it retains about, on average, 80% right across the board. So it's still not as good. You know, you wouldn't use it in a primary structure in an aeroplane.
Okay.
Please don't use it in a primary structure in a wing. But you would use it in a secondary or third level structure in a plane. You'd use it as interiors. You know, in automotive, you might use it as an interlayer, as a dampening interlayer. We've been working with a lot of sporting companies that definitely see a reduction in vibration in the tennis racket, the hockey stick, the bike wheel, the bike frame, which then translates to the person holding it.
Yeah.
So, for instance, in a tennis racket, you might not get tennis elbow as much because it's not transferring that load up into your elbow. So it's a really cool kind of process, unique material.
Talking about sustainability, let's go for a second down the route of environmental impacts. If I want to compare the environmental impacts of a virgin carbon fiber versus one coming out from Lineat process, what are the differences?
So when we first started talking about this, you know, it's carbon fiber has a dirty secret, and the fact it is not the best material to make anything from as far as its CO2 footprint.
Yeah.
You know, because of the energy required to manufacture it in the first place, we're talking between 30 to 100 kilograms of CO2 per kilogram of material made. People do forget that. So the aerospace, which is a higher grade, it is up to the 60, 70 kilograms of CO2 produced. When you're talking about steel, which is less than 2, aluminium 6, and they're looking at sustainable and recyclable aluminiums now, so that's coming down. Our process sits around about the 2
You know
to
your
3.
numbers. I'm so happy.
That's the only numbers I know, Francesco. These that ask me for any my birthday, and that's about it. But
don't give us your PIN number. No, what were you just about to say, Gary? But Lineat sits at what number? Sorry.
Lineat sits around about the 2 to 3 kilograms.
You joke, really?
But then remember, you do have to add the reclamation process as well.
Yeah.
Okay,
and,
sure.
and that's pyrolysis, solvolysis. But some of the latest pyrolysis and solvolysis systems are down at the 3 to 4. So it can sit just underneath aluminium.
Right.
And that's why the high-end automotive are looking at it, because we all know that, if you buy your Lamborghini or your Ferrari like we do, that's got carbon fiber in.
Yeah.
But if you buy your Ford, there's probably not a lot of carbon fiber in. It's very expensive, very wasteful, very slow to manufacture. And also it's got a high CO2 footprint. So if you're trying to reduce the footprint of your product, be it a car or be it a TV, you need to look at alternative materials. But in the same time, you need to reduce the weight. The default material is carbon fiber, because everybody knows it's ultra strong for its weight. So people just go, well, we'll use carbon fiber. And then somebody says, well, what about its CO2 footprint?
Yeah.
And that's where everybody kind of, right. And you either ignore that and just press ahead. But if you're, really focused on the sustainability, which a lot of the big companies are now, and that's their driving, they've made those commitments, recycled carbon fiber suddenly becomes usable.
What happened though if you want to keep your product in the loop? Can I recycle it again? Because aluminium, for example, scrap aluminium from the 6-7 original kilogram of CO2 per kilo of product, when it goes back from scrap, it becomes 0.6, 0.8 kilograms. So can we do the same? Can we put it back into the system?
100%. And
really?
As I said before, our process takes short fibers. So there's a process to reduce the size. Once you've made a component out of our material, you've already got that material, that fiber at the right size. So it just has to go through the reclamation, the process again, and you have the fibers again. We can put them through our process again. We have managed to recycle it 3 to 4 times
Nice.
in the lab without
Yeah.
any reduction in properties.
Ooh, that's attractive.
And you can imagine that a lot of carbon fiber, like a plane, has a life of 40 years.
Yeah.
So that's quite a long time.
That's extraordinary, Gary. That is a game changer, though. It actually, in a way, it is fantastic that it is going to reuse that 40 or even more % of waste that is generated during the normal manufacturing processes. On the other hand, it means that there might be an even more augmented production of carbon fiber because now you close the loop.
Yeah, no, exactly. And I think what's happened, and this was a number of years ago when the supply of carbon fiber, because more people are using it, as you say, it's growing. I don't know what the exact number is, like 15% per annum.
Mm-hmm.
It's growing, and it's being used more in wind turbine blades. So the longer the blade, the stiffer it is, and the stiffening piece is the carbon fiber within the glass fiber.
Yes.
So they're using more and more carbon fiber in the renewable sector. Aerospace used to be the biggest user, and I'm sure there'll be lots of numbers out next week at the JEC Composites Expo. I think wind turbine is taking over that as the volume.
Yeah.
So therefore, there's a big amount of feedstock waste that's going to be when they decommission these these blades. Sorry, there's going to be a lot of carbon fiber around the marketplace.
Oh yeah, huge.
So
Lots of raw materials for you. Sorry.
Yeah.
Yeah.
No, let's stay in this. So I can see the need for the large infrastructure projects, the wind turbines and the aeroplanes, things, as you say, that hang around for sort of 40 years or so. But I can certainly also see the need in other sectors, as you've mentioned, with cars and automotive, particularly when we're moving to EVs. Lightness is key, but also sort of consumer goods and things as well. When we look at our phones and our laptops, all this stuff needs really good rigidity and durability, but at the same time to be light and easy. So what are the sectors and companies and markets are you talking to, Gary, where you see opportunities?
So we're actually talking. So first of all, we started with the sport. So we love speaking to sporting companies. They're very quick to get product or test out there. Nice. They're very innovative. They're not really constrained by regulation or legislation. They can do whatever they want, really. You know, if a tennis racket breaks, it's not a big problem. If a wing falls off a plane, probably quite a big problem.
Yeah.
So therefore, we are kind of low-hanging fruit with a lot of the sporting companies, so consumer goods. And it is interesting it's a good question, actually, Anne, because when we first spoke with the sporting companies, they weren't looking at it from a sustainability angle. They were looking at it from, we can sell more product. You know, and realistically, if a tennis racket lasts 20 years, that's really bad for the tennis company.
Right.
They've got to be bringing out new products all the time to attract people. But with this, we can take their old ones. That's fine if they buy a new tennis racket every few years, if they think they're going to play better, which we all know won't make them play better. But let's not go there.
It will, because it will soften their hit
right.
and that vibrations.
Yes, of course they will. Yeah, well done. Good. Well listened. Yeah. And I think especially when you look at the economics, you know, when you're say you're manufacturing in Asia and you're shipping millions of goods, whether they be sporting goods, electronics, whatever, every single one of those has a mass to it, a weight, which has to be either shipped or flown around the world. If you can reduce that weight by a few grams, 5%, 10%, that has a massive knock-on effect onto the CO2 of the shipping as well. So all these things count. But so we've been working with a couple of electronics brands, the sporting companies we're speaking to. You know, we're speaking to Bauer Ice Hockey, we're speaking to Wilson, Head, a lot of the top brand bike companies, because the sustainability draws them in. Of course it does. Everybody wants to talk about sustainability, but it's those unique properties where the engineers get involved. You know, the marketing people love the sustainability bit.
Yeah.
But it has to be a
nice
viable material. It has to be a viable material that does the job. I guess what we haven't touched on, and maybe I'm jumping the gun here a bit, is
the price. You gotta
no,
tell
no,
me
no,
the
no. Actually,
price.
I wasn't going to mention
go
that.
around.
No. So let's talk about price. Okay. So you can imagine our biggest cost is our feedstock. It's the reclaimed fibers. That is our biggest. It's a paper process. We're mixing these fibers in water. You know, fully automated. Our pilot line that I can hear humming in the background down below, is being manned by one person. It produces material 8 hours a day, 5 days a week. There's not a lot of cost associated with that. We've got energy, yes, that's which of course goes up, but it's that feedstock of reclaimed fibers, and that I'd say is an issue at the moment because it's not a component. It's not a commodity. It's not a commodity. Therefore, the price varies quite a lot. When there's a lot of it, the price is low. When there's not so much, the price is high. So that it is. But we're costing that we can be underneath virgin carbon fiber in kind of 2 to 3 years with scaling the machinery up.
Okay.
Which will allow people to use. And when you're using lots of material, the price is very, very specific. But what we've found is that people are actually making a hybrid component. So they're utilizing the special properties of our material with virgin carbon fiber. So if you want so you might lay up a component, 6 layers of virgin, unidirectional to get the tensile strength. And then you might use 3 layers of ours to maybe dampen the product or give a better surface finish and things like that. So the price is achievable. It's down to our feedstock. But as we mentioned a minute ago, with things like wind turbine blades coming online, that feedstock is going to grow and grow and grow. So the price of that will start to come down.
You also have regulations that should be playing in your favor, right? When we first met, Gary, you talked to us about EU regulations where carbon fiber cannot be landfilled, for example.
No, exactly.
Solve that problem. Yeah.
That's the point I was going to make, Francesco. I was going to jump on the price bag. You jumped on the price bandwagon,
price.
No, I was going to say legislation, especially in the bigger sectors, aerospace, automotive, they are looking into it because they're being forced to look into it.
Okay.
And yeah, some certain countries in Europe, you're not allowed to landfill carbon fiber. I think I'm right here, and please don't contact us, but in the in the UK, you're not allowed to landfill uncured carbon fiber and resin. You have to cure it. So if you're manufacturing a component and you snip a bit of material off, and that's resin, you have to cure that resin in an oven before you can put it into the bin.
Oh, wow.
It's from an environmental perspective. You've got chemicals in there that could seep into the ground.
Articulates from the carbon fiber.
Exactly.
Too.
If they're not cured. Once they're cured, they're solid. Not a lot will happen with that for tens, hundreds of years. So
yeah.
But the legislation is becoming stronger and stronger.
Well, if you can arrive to market with an offer like that, it is a no-brainer. I was surprised to hear from you that your major cost it is actually the feed material, the reclaimed carbon fiber. Because I thought, okay, this is a pain in the ass for manufacturers to deal with. I come as Lineat and say, hey, I solved the problem for you. Give me your waste material. I'll handle it. For you, so I was expecting not that to be your big cost. Like for example, another recycling tech, they give away for free some sort of plastics or any other waste material.
They do, Francesco, right to the point where they say there's a value with it, and then they don't give it away for free.
Yeah.
I've seen that right across all the. When you I remember. A long time ago, I worked with a company and they were making airbags.
Yeah.
And they were cutting airbags out of a heavy polyester material, and the wastage was about 15%, but they were making millions and millions of airbags.
Yeah.
The company in question made more from the waste than they did from cutting out the airbags.
Okay.
Until the person they were doing it for said, please send the waste as well. So they lost that. So there's money to be made into that, but feedstock. What we're trying to do to really complete that, we're working with several of the OEM carbon manufacturers that have waste at the very beginning, that they don't know what to do with it. It doesn't go into any of their product range at the moment. So we're trying to take that waste, and we're working with Toray, Protasian, Hexcel, Syensqo, lots of the global carbon fiber manufacturers around the world, taking their waste, making it into our material, and supplying it back to them.
Well, if you,
so in a way,
I don't know how big is your tech,
free.
But you can literally bring it to them, put it into a 20-foot container, and bring it to them on site, and do that batch production. I'm just throwing ideas. Yeah.
No, that's something. I like the way you say 20-foot. It was a 40-foot container, the original idea, because it's factory in a box, I think, is the buzzword. About 5 years ago, that's what everybody was throwing around. When you let your designers and engineers free, it doesn't really work like that. They design it as it's supposed to be.
That.
So I'm sure we can fit it into a 40-foot container. But no, the idea is, because as a kind of environmentalist, sustainable, driver, we shouldn't be shipping waste carbon fiber halfway around the world. It should be where the waste is. So, in the future, we will have a plant next to a carbon fiber manufacturer. Their waste will go directly into it. Our product will then go back into their factory to either have resin applied or combined with some of their virgin.
Beautiful. Like that a lot. On site, reduce that emissions. You also reduce those building emissions to build your facility to do stuff, because they will be packed into a 40-foot container.
And of course, the accountants love it.
Oh,
because there's a waste in there that has a number sat next to it, and if they can turn that into profit, then it's good for everybody.
Yeah, value. So what's next for Lineat? Well, you build your pilot plant, right? Which is able to produce how much per year? How many tons per year?
The process that we have today in the pilot line down below is around about 2 to 3 tons a year.
Okay.
We're just upgrading that to a new upgrade, and I can't really say too much, but allow us to do between 9 and 12 tons on the pilot line.
Mm-hmm.
And then it's a matter of expansion. It's about
Yeah.
multiple machines, and we also are working on an industrial scale, because unfortunately it's not a scalable process. It isn't, copy paste, make it 10 times bigger, quicker. There are limits to the technology. So we've kind of found the limits with our pilot line first production machine, which is about 9 to 12 tons, which is adequate. But for the big numbers, because there are hundreds of tons of waste out there just for manufacturing, let alone end of life, there must be tens of thousands, hundreds of thousands of tons.
Yeah.
We have to have a process that can accommodate that. So we've been developing, we just patented a new process, which is different than the current process, which will allow us a 10 times production rate of that.
Okay. Wow. What about the
So
output?
that's kind of where we're trying to run at the moment to keep up with the market and demand.
What about the output quality? Will still retain the same properties?
Yeah, so that's a really good question, because people are used to looking at the carbon fiber and know exactly what the properties and also the quality is going through the whole production. Because our material is made up between 4 and 6 mil fibers, you can see there's going to be some variation in that.
Yeah.
So we're coming up internally, and we have two large projects at the moment. One's with JLR about scaling up our technology.
Nice.
For the materials to go into the SUV range. And the other one is with GK and Aerospace. And that is purely our part of the project, is looking at the quality control of our material. And we've come up with some really cool inline processes, AI cameras, looking at the alignment of the individual fibers, transferring that back to a PC so we can look at the properties that we're going.
Spectacular.
You told us a good story before, Gary, about JLR and the weight of their, is it the Range Rover going out?
I think it's a Range Rover, yeah.
Tell us that story.
I think this is quite point. Everybody talks about, sustainability, electric vehicles, electric EV, lithium ion batteries are pretty heavy.
Mm-hmm.
So if you fill a Range Rover up with lithium ion batteries to go fully electric, because it's such a large vehicle, it kind of goes over I think 3,500 kilos, which then makes it a commercial vehicle.
Yeah.
So all those lovely people driving around Chelsea in their Chelsea tractors will have to go out and resit their licenses and get a commercial lorry driver's license.
HGV license for their Range Rover.
Yeah, it'd be fantastic. There'd be lots of school runs with high-vis jackets and beer bellies, but I do generalize lorry drivers there, so apologies for that. But yeah, so what do you do? How can you lightweight something? And as we said at the very beginning of the chat, carbon fiber is the default material. Just to say, we will use carbon fiber. Brilliant. End of. Solved. Then you look at the CO2 footprint of virgin carbon fiber and say, well, we can't, because we're currently using aluminium at 6 kilograms, and we're looking for an overall footprint of that vehicle and tailpipe emissions, etc. We can't go and use something that's 40 kilograms. So that's kind of where the interest in Lineat came. And yeah, we've got a really good relationship with Jaguar Land Rover. We're looking to push on that and drive that forward.
That's
great. Fantastic.
Now, look, Green Angel Ventures is actually an investor in Lineat, so I do not want to distract you, and I do want to keep you very much focused on carbon fiber. But indulge me this question, Gary, because I'm just curious as to the technology you've developed and what you've learnt in this space. Are there other markets such as different fibers, basalt fibers, natural fibers, or other kind of recycled composites that could sort of be a future market for you?
Well, the process in itself, when it was developed at the university, was to make hybrid materials. So bringing, originally, I think it was glass and carbon together. and get the ductile properties of glass in with the tensile strength of carbon fiber.
Nice.
That's great in academia. They can spend years and years developing that, tweaking that to get the perfect material. We have run different fibers through our process. Some of them I can't really divulge. Natural fibers, probably not, because it has to mix in water. So if you think about hemp, things like that,
Yeah, flaxseed. Yeah,
flax, they float.
yeah,
Okay.
So yeah, I think the specific modulus is below 1, so it kind of floats.
Flax is
Which
very
is
popular in the boating industry now. I
exactly,
hear a
yeah.
lot.
No,
Yeah.
we have another project with Green Boats of Germany, and they make a lot of boats out of natural fibers. But what you've got there is it's a really good product, but the specification and properties are not fantastic. So what people are doing, and we're championing this, is mixing our fibers and their fibers up in a specific layup. So you get the strength of our material, and you get the natural feel of their material as well. So
Interesting.
but yeah, no, we are looking at lots of different fibers in other industries. Hydrogen fuel cells, they use carbon fiber through material conductivity. So there's very specific, as you say, basalt, ceramic fibers, all these. It's just time. It really is. The R&D team would love to start, really going in deep into those. But when we have an interest from a customer or partner, then we start. We are doing quite a stringent R&D work at the moment on different fibers.
Very interesting. Thank you, Gary. This is it is very nice to hear that you can achieve both that environmental and financial goals through your technology. Em and I are advocating a lot that any climate tax needs to deliver on both. You cannot just go out on the market with good purposes, good environmental purposes. You need to deliver also on the financials. Otherwise, the market, the pie, it is shrinking. The availability of funding for the pie, it is there, but it is way more laser focused on something that can deliver stuff. So I'm very happy to hear that you got on your hand.
Yeah, no, I think that's the driver. My background's commercial, my background's sales, and it's always driving that it has to be economical to use the material.
Has to make
because
sense. Yeah.
When it's just a sustainable green material, the first thing people ask is it cheaper?
Yeah.
And if it isn't, if they're not forced to do it by legislation, then they won't do it.
Let me summarize it. There is no more green premium. There shouldn't be any more green premium. Okay. You can accept it at the early stage of our technologies because we are developing technologies and we bring it up to par. But when you are at that maturity stage, there shouldn't be any more green premium. If not, there should be a green discount rather than a green premium. That's how it should work.
And I think that's why having these kind of unique properties, dampening, vibration, formability, those are opening people's eyes and going, okay, I'm not looking at this as a green material. I'm looking at it as a new material.
Yeah.
When we've had meetings with kind of Department of Business and Trade, it's like, this is a new material. They're not saying it's a green material. It's a new material. Yeah. And this has its origins back in the 80s and 90s when they were trying to develop a flexible and formable carbon fiber. It wasn't invented to try and recycle. It was to try and develop the most formable carbon fiber, because that's one of its down points.
Nice. Wonderful. Thank you, Gary. This was a lovely conversation. We have the time flied like crazy fast.
Wow.
Thank you very much for your time. Good luck with the next stages of your journey with Lineat, and look to catch up with you again very soon.
Definitely. Thank you very much.
Thank you, guys.
Thank you. I'll talk to you soon. Ciao, bye.
Bye.
Thanks for listening to this episode of Raw Green. If you made it this far, you probably enjoyed it. So don't forget to hit subscribe and follow our podcast. It's an awesome way to support our community. At Obi, we're all about research, life cycle assessment, and green tech innovation. Stay in touch through our socials or visit our website. Links are ready for you in the description. Catch you in the next episode. Ciao!